That's something that you could specifically answer and find out. That's what I'm going to say. But the answer has already been given, but it's not been accepted. So maybe we need to take it to the next level and figure something out where we can use actual numbers. Right? I think so.
No, I mean, I disagree with you. I think, we need an explanation. We need to have clarity about what's going on, about the concept of these different speeds. And then we could have an example which, illustrates that concept that's been made clear, right? But
if someone then wants to...
Planes land every day, right? They land every single day as if it's stationary, right? We know they don't have to worry about a ground pass. We know they don't have to worry about a destination. We know that a pilot can just fly wherever he wants. He's going to always be able to treat the Earth as stationary, even if the ground is moving twice as fast as where he took off from. So the answer to that should be, unless the Earth is stationary, there should be a very well-known answer, and it can't just be the atmosphere, because the atmosphere is not said to be in lockstep, and the atmosphere has winds going in all directions. So that's a non-answer. So this is what I think proves that.
No, you're just wrong about that last part you said. You just keep saying that, and it's incorrect.
You said
wait, hold on. Hey, Hugh, hold on. Big Tech said I was wrong about something. What was I wrong about?
Okay.
What was I wrong about?
When you say that the atmosphere is not in lockstep, you're implying that creates a problem, and it doesn't.
Why wouldn't it?
Because it's very close to lockstep, number one. And number two, all he has to do is navigate through the air, choosing the proper heading and airspeed, and then lock in on the landing when he's in proximity to the landing strip. So saying it's not in lockstep, you need to be more specific about how much is not in lockstep. For example, many of the winds, including the trade winds and the jet stream, they blow in the opposite direction that the Earth is curving. So they actually would help him. So it's not even, they're like going faster than the Earth.
Well, see, that's the thing is like on your side of their argument, estimation words start to be used as if like that would help the argument. Like it would help him with the jet streams moving faster because he needs help getting to be faster eastward, or the atmosphere is helping him move eastward, even though he's steering the plane somehow to also keep up with the rotation. So these things need to be dispelled and knocked down one by one. First of all, he never does anything. The pilot never does, don't interrupt. The pilot never does anything to try to compensate for rotation whatsoever. He just treats it as stationary. So there's no compensation ever on a pilot's part to try to match the eastward rotation. It's just stationary relative to the plane always. Now, how the plane could be always complete, how the Earth could be completely stationary no matter what the pilot does with the plane is the question we're trying to get to. Now, if the jet stream is moving them faster than the rotation of the Earth, let's say 200 at least, right? 200 miles per hour faster than the rotation, right? So when he jumps out of that jet stream, how is he in sync with Earth again, Big Tech? Because he's moving 200 miles per hour faster with the jet stream. Does he have to slow the plane down to match the rotation again?
So it says here that the jet stream...
do you think that planes can speed up and slow down? Like, I don't get the problem.
Wait, no, that's a straw man. Hugh, will you please not interrupt?
Yeah.
I'm going to go back and forth with Big Tech on this issue.
I will. To be fair, he wasn't interrupting. He was trying to jump in.
Please not interrupt anybody else. I want to go through this with Big Tech right now.
Some moderation, new perspective. Just 1 second. So, you were asked a question, Big Tech. You could answer, but then you want to get in, so you got next.
Yeah, thank you.
Well, he just said. Wait, hold on. He just said. I said that planes can't speed up and slow down. I never said that. I asked, do you think the pilot slows the plane down so that he can match the rotation that would be different than where he's at when he comes out of a 200 mile per hour jet stream? Do you think he has any kind of like knowledge that the Earth is rotating at a different speed than he is? Is that what you're saying?
It's not.
Okay, may I jump in now?
He's not
what are you
flying.
Saying? No, Hugh, don't interrupt. Let him go.
He's flying through the air. So he chooses airspeed, and he chooses a heading, which is relating to geographic locations on the ground. So airspeed plus heading equals destination, and that's it. And it's not like if the jet stream's going 200 miles an hour, that makes him 200 miles an hour too fast. He just, whatever cruising speed he wants, he he can use the jet stream as a boost, so he uses less fuel. Or if he's going against it, he has to consume more fuel. He has to accelerate harder with the engines. He's just throttling up and throttling down to get the speed that he wants related to the ground, and he's choosing the heading to get where he wants to go. So since it's all a totally dynamic thing, there's not some moment where he would have to calculate how fast was the Earth going there and how fast is it going here. He's always modulating according to airspeed. And the air is what he's flying
All of
through.
that,
And the air is
everything you
moving
just said is
generally
true.
with the Earth, sometimes faster, sometimes slower.
Generally,
It
an
makes no
estimation word.
difference.
Generally is an
But it-
estimation word, right?
Yeah, but it makes no difference. Faster or slower.
Does he have to
chooses his
estimate?
heading
Does
and
he
his
have to
airspeed.
estimate? Like, does he have to? Does he ever have to estimate when he's landing to be like pretty much in sync with the rotation? Is that ever a thing that like he could be a little bit too much not in sync? Like, is it ever just like, oh wait, the atmosphere was, not keeping me up enough to be in sync this time, so I'm going to have to make sure my plane goes eastward a little faster so I can treat the Earth as stationary. Has that ever been even a smidgen of a problem ever?
Yes, and I'm going to tell you why. Ready?
Don't compare it to wind.
Uh-oh. Because here's the thing.
Yo,
Winds
Wait a minute.
moving the plane are a totally different thing to deal with than the rotation being out of sync
Hold
with the
on.
Earth.
No, this is where you're having an issue. When we talk about air moving not with the Earth, we call that wind.
Exactly. So
Okay,
you're saying
So
real
it's
quick,
wind,
I wanna
yes,
jump
he
in before we
compensates
move on.
for wind.
So you're saying that the
my guy.
air that's in sync with the Earth would be no wind, right? So the no wind air is what keeps the plane in sync. So when it's no wind, that's the air that's moving the plane twice as fast eastward. Is that what you're saying? The not wind, the no wind, because the wind's moving all directions, right?
So
That's when the
like for
Earth
the
is
thought
not in sync.
experiment, you're saying like would it help if with this question if we go, let's assume that the air doesn't move at all?
Well, that's what
It's
they
perfectly
say when the
still his
air
whole
doesn't move.
if the
Yeah, that's
wind
what
if the
the
air was
ballers
perfectly
say.
still
It's
for
in
his whole
sync.
journey.
No, they're saying that when there's no wind, that's when the atmosphere is in perfect sync with the Earth. That's when there's no
Yes.
wind.
Yeah, and
Right.
sometimes it is.
You're saying that
depending-
that's
Yo, I want to jump in.
but
Cloud, don't lose your point. Okay, keep your point. And, like,
air with no wind is what keeps what accelerates the plane. We've already agreed that the plane would have to be going twice as fast eastward. What makes the plane go exactly twice as fast eastward, not 5 miles an hour too much or a little less? He comes out of a jet stream, he's going 200 miles per hour than the supposed rotation, right? So how is it when he comes out of the jet stream, he's going 200 miles an hour faster than the rotation supposedly is? How is it that he never sees the Earth moving at a different speed underneath him? He's got to conserve momentum of that 200 mile an hour jet stream. Why wouldn't he just be able to stick a camera out the window and show the Earth moving east to west as he flies south or north?
Because he's going 200 miles an hour in relation to the Earth.
No, the rotation, they say, is 1,000 miles an hour at the equator. If you're in a jet stream, that means you're going 200 miles per hour faster than the rotation.
No.
Yeah,
No.
that's what the globe says.
No, Mike, dude.
Here's a thought
they say
experiment. Let's say, hold up. Let's say there's vehicle going downhill at a constant rate, right? And you just you were just dropped into the vehicle. Okay, let's say it's constantly going down 100 kilometers an hour, right? And you're just dropped in while like on the side of this mountain, side of this hill. You're dropped into this car, and it's going down. You're saying you throttle up, throttle down. That's all you have to do. If you're going down like in this car and it's constantly like going down at 100 kilometers an hour, all you're gonna do to get to your destination at the bottom of the hill is hold the brakes. All you're gonna do is gonna slow down the vehicle. Similarly, if you're on the equator and you take off from there and it's 1,000 miles and then you're going to a latitude like north or south or whatever, all you're gonna be doing is slowing down apparently. Until you reach like 500 kilometers an hour or whatever. I mean 500 miles an hour or whatever, and then you're gonna slow down until you land. Apparently, the only thing you're gonna be doing is slowing down.
Okay. Do I have space to jump in? The
plane just speeds up and slows down through the air.
Okay.
I'm not even sure what you were trying to say there. I'm not even sure.
Let me get in because I actually read.
Go ahead.
Not Rebellion. I've got the answer. I'll go through a few things. If you look at the latitude difference between LON and LAX, I've done that bit. If you look at the latitude, it's not that great. So the change in speed is not going to be very great. But let's say you would just go north to south. Then there's a change in tangential speed, right? The rotational speed relative, right? So
Yeah, that's what we're talking about. North.
okay. Let me see. How far is that from the North Pole? Let's say you're North Pole to the equator. What's the distance? A few thousand miles, right? Some thousands of miles. Okay. If you're at the North Pole, how fast is the wind blowing? Let's say the wind is blowing 10 miles an hour. How fast is the wind actually blowing?
You mean in
Right, because
relation to the
wind is equal, but
universe?
let's say wind is equal between
Yeah.
both locations.
Okay, so it's say 10 miles an hour, okay? But at the pole, it's not really moving hardly at all, only 10 miles an hour. But the
Going
rotational speed...
66,010 miles an hour around the sun.
There you go. But at the equator, it's going 1,000 miles an hour.
67,000 miles an hour.
Okay, but if you're in the air, then and you've at the equator and you have an airspeed of 10 miles an hour, when you take
Pardon
off...
the interruption, but would that not be wind? Isn't wind a disparity between like the air and the ground?
Yes.
Yeah.
So it wouldn't be wind.
So
then,
if you...
because, it's
Right,
lockstep.
so if...
Wait a minute.
Yeah. So
Can
if
I
you
interject? Would it throw you off if I interject right now? I think I just discovered the answer to this man's question that
yes.
I finally determined.
I think you're ahead. You know what? I think you're thinking the same thing I am. What I'm thinking of is 10 miles an hour at the pole, 10 miles an hour at the equator. It's still just 10 miles an hour.
Well, no, I was just joking and I was kidding. But look,
okay. Go ahead.
When he says 1,000 miles an hour versus let's say halfway up to the pole, it's like half that, 500, right? He was brought it up a few times, so let's give it that. So it's a 500 mile an hour difference.
Okay.
What he's talking about is absolute speed. It's not relative to the ground. It's relative
Correct.
to space. We're talking about
Yes.
at the equator, you're going 1,000 miles an hour relative to space. So velocity is relative to something. So
but that's what the airspeed is.
Yeah. So exactly. So the airspeed is something else. So what is actually difference? It's the difference between 67,000 miles an hour and 66,500 miles an hour. So the difference is whatever that percentage is between 67,000 miles an hour and 66,500 miles an hour. Figure out the percentage difference there, and yeah, that's how much he has to compensate. A fraction of a fraction of a fraction of a fraction of a percent.
Big tech. No, the literal speed is 1,000 miles an hour. They claim for the globe.
Literal speed relative to what?
Relative to the 500 that he was spinning with the Earth when he took off.
But speed relative to what? Relative to
the zero at the poles, bro.
Or the poles.
Yeah, it's relative. Your answer is not working.
Not relative to space.
It's not about relativity. It's not about a reference frame from space or any of those kind of percentages. The literal speed they say on the globe would be 1,000 miles an hour. And yes, the plane would have to be moving eastward at exactly 1,000 miles an hour for the pilot to treat the Earth as stationary there. Now, if he only started with a conserved momentum of 500, or worse yet, if he came from the pole where he was supposedly not spinning at all, 0 or even 10, then the plane would have to be accelerated to 1,000 miles an hour eastward, regardless of the direction that the pilot flies, regardless of anything the pilot does, regardless if he has no direction except to go, west-southwest generally. And he's going to get to a spot where he can always treat the Earth as stationary without him doing anything to worry about the rotation. But he literally would have to be going 1,000 miles an hour in perfect sync with the ground to treat it as stationary. That's what the globe claims.
Okay,
wait.
He's
No.
flying.
Everything you just said is wrong because he's not going 1,000 miles an hour relative to the ground.
No, he'd have to be in sync with the 1,000 miles an hour rotation to treat it as stationary. He has to be moving with the Earth in such perfect sync.
Exactly. But what's his airspeed what's his airspeed at that moment?
But see, those things are not relative to rotation. Airspeed and ground speed are always assuming a stationary ground as well.
No, they're not. They're assuming they're relative to the ground. They're just relative to whatever the ground is doing.
You're saying the ground speed is the speed of the plane relative to the ground, but it's not relative to a rotating ground. It's not relative to a rotating ground that's doing twice as fast as
because that's not how it works. They'd say it's in lockstep, so it's relative to a stationary ground.
Okay, but here's the answer. I mean, I know you brought up the train. Like if the train
from wind, wind is the disparity. Wind is the disparity between the air and the ground.
if I'm in a train that's moving 50 miles an hour and I get out of my out of my seat and I want to walk down the aisle, I don't have to get going 50 miles an hour and then catch up with the train. I just go.
That's a non
Just take a
sequitur.
step.
That's one reference frame. You're in the same reference frame in a locked cabin. You're in that reference frame. When you're in a plane, according to the Coriolis claims you were talking about with the bullet earlier, that's a problem. And it's not about the Coriolis effect. That gets conflated. That has to do with Sagnac and the corrections that are east to west only. And it's very slight. And yes, it would be hidden in the winds. Winds would be overcoming any kind of Coriolis force, which would be a westward deviation headed towards the equator, and it would be pushing the plane westward, not eastward, to keep him up with the Earth. That he would literally have to be going twice as fast. That's not an argument that I'm just interpreting wrong. Everyone here knows they've been through this long enough.
The train analogy is correct.
Miles an hour, literally.
I'm crossing out the train.
Momentum.
The
You're
train
in one reference frame. You don't have two different reference frames. You're not in a separate reference frame. You're inside the train of a car. You have inertial and non-inertial reference frames when you're talking about airplanes in the ground.
Yeah,
the atmosphere turns with the Earth. So since the atmosphere turns with the Earth,
but it's not even said to be in lockstep.
It's very close.
How far out?
When you say, okay, hold on. When you walk outside your house, do you feel 1,000-mile-an-hour wind trying to blow you over?
That's not what I'm saying.
It's the same reference frame in one latitude. But as soon as you start switching latitudes, then you're switching reference frame.
Yeah, you're in a different reference frame. That's not arguable. It's not the same as being on a car.
That is true.
Yo, Matthew Lawrence, can we get like a fourth opinion here? A fourth global opinion?
I've got the answer. If you are on the Earth at the equator and the wind speed is 0, the wind speed is effectively 1,000 miles an hour. If you're then
that's the idea. Either that or the Earth is stationary and there's no wind.
If you're halfway to the pole, then the wind speed there effectively is 500 miles an hour. But so 500 miles an hour.
Wrong though, because the wind speed's not 500 miles an hour because it's stationary. That's how you think of it kinematically. Because there's no wind, all of the air must be in sync with the rotation. Or you're just on a stationary Earth and there's no wind. It's one of the two, right? But if you have winds going in all directions, it messes it all up. You got winds going the opposite direction.
Okay.
The wind speed is relative. It would be the airspeed at the equator would be 1,000 relative to the air at the pole, which would be 0. It's always relative to the poles, which is the 0. That's the control basically, right? So the ground speed at the equator is 1,000 relative to the 0 at the pole, and the air and the ground are in lockstep. They're synced, so that's why you treat it you treat the local ground as stationary. The wind is the disparity. The wind will be plus or minus 1,000. Whether it's blowing east or west or whatever it is, or north south. That changes the synchronicity that you have between the air and the ground.
You see, the whole thing is such a kinematic concept, and they have to. Okay, so the claim is that the difference between the atmosphere rotation and the ground rotation is what creates the dynamic system that we call weather, with different rotating left or right, one side of the equator to the other, right? So that's what causes the dynamic system. But then at the same time, you're saying the atmosphere is also carrying all of those weather systems, those dynamic weather systems, as well as accelerating the plane, as well as all these other, it's carrying it in a static relationship to each other, right? As well as not being in sync to create the dynamic system, but keeping the whole dynamic system in perfect sync. So it's a total contradiction, a complete failure to maintain complete logic.
How far out of sync is it? How far out of sync is it?
Let's let Red Cloud finish his stuff. We're gonna jump.
It's not determinable. It's just an idea. It's just a concept that it's in sync. Right? It's just a concept.
Well, you keep saying it's out of sync. How much?
Hold up, bro. Let Red Cloud. He's been trying to get in, so let him finish his point.
I don't know. Is it more and less or out of sync? Does the globe claim it's sometimes more in sync, sometimes less in sync, or what? What does the globe claim?
Well, you're saying there's a problem. How much of a problem?
Hold on, guys. If you allow, just let. He's been trying to he's chopping at the bit to say his piece. So let him say.
The problem is I just forget things easily. So here's the thing: the problem you are trying. I feel like you're trying to make a problem. I really do. Sorry, but I think you're trying to make a problem. The other thing is, it's only half a problem.
Okay, well, no, let's go past that.
It
What's the
really is
problem?
only.
Please let him finish what he's saying.
Steelman. Steelman the argument.
Okay, let me finish. Thank you. So it really only is an argument if you're going north to south. It isn't a problem if you're going south to north, because technically the speed will be decreasing, wouldn't it? So that's not a problem. And if that's not a problem,
why wouldn't it be a problem either way? Wait, so the pilot never slows the plane down to be. The pilot never slows the plane down so he's moving, so he can land on a part of the Earth that's moving slower than where he took off from. Just like he never speeds the plane up to move on a faster part of the Earth. None of that's the pilot.
That's my analogy of being dropped down on the side of the hill and just constantly slowing down as you get to your destination.
The problem doesn't exist because the difference in speed of air changes as you go north to south. If you're in the north and the speed of air is 0, that speed, if you're at the North Pole, is going nothing. And if you're at the equator, it's doing 1,000 miles an hour, but it's actually doing nothing. If you fly up, right, and then you fly along, then the change in airspeed will effectively get less and less and less until you get to the North Pole. You're flying through the air. You're not driving along the ground. You're flying through the air.
You got winds going the opposite direction. What if you got the westward winds pushing the plane in the opposite direction of the one that you need? You need the air to move the plane faster eastward only, but you have strong westward winds the whole time you're there. How could you say on a day that there was strong westward winds that the air carried the plane the exact same amount no matter what? No matter if there was westward winds or eastward winds, you're saying that the air carries it and just subtracts those. That's why it becomes kinematic. You can just mathematically think, well, it needs to be going 1,000 miles an hour. So in my concept of the atmosphere moving the plane, regardless of all the winds, I'm just going to think that the plane is moving in lockstep, even though the atmosphere is not said to be in lockstep. But it's okay. It can move the plane backwards as it's circling the airport. It can move the plane. And even though the pilot only knows he's going 100 miles an hour in a circle around the airport, the air is also carrying him 1,000 miles an hour eastward consistently, so consistently that it doesn't matter at all because the pilot's just going around in a little circle 100 miles an hour. And somehow it's also being accelerated perfectly the whole time, faster than where he took off from.
The only answer that I can come up with is that the pilot is oblivious.
Complete violation of the conservation of momentum and the conservation of energy. It completely violates all the laws. Even a plane that goes high enough up would have to be moved faster to be in sync with the Earth. And there's no mechanism. There's no mechanism, you guys. You guys have no mechanism. You have no dynamics. It's only a kinematic concept that allows you to keep believing it.
Yeah, but it's not much. Do you know
I got
the
a
numbers?
new question. I got to throw this one in there. So
I could give you the numbers.
Everybody knows about a carousel.
I'm sure you can.
So there's a carousel with 3 lines of the little horsey unicorns that the kids are riding on, right? So the kid on the inner ring of unicorns is going slower than the kid on the outer ring of unicorns. But he wants to move out to the outer ring, which is going faster. Does he have to do any calculations? Or doesn't he just aim at it and walk over there?
Yeah, how does he do that?
He's on the same reference frame. He's staying on the ground. He's on that reference frame. So you have an inertial and a non-inertial reference frame. Once you leave the ground, you're in a non-inertial reference frame. Once you leave the ground, you're in the inertial reference frame and you're moving separately from the ground. Just like when we started Big Tech. We started with this, right? You jump up in the air. The reason that you're still in sync with the Earth is because you were on the Earth, right? That's the reason that they claim that you stay in sync when you're at the same latitude. But when you go to a place where there's twice the amount of speed eastward, you have no answer, and it breaks the globe model. Because you can't say the air pushed them twice as fast, regardless of what the pilot did or what the winds did. It just worked out perfectly.
Why can't you say that?
Why can't you say that? But you know the dynamics don't match that. You can't. There's no forces and no mechanism to claim or identify. There's nothing. He just treats it as stationary no matter where he is. Even though the claim is it's moving twice as fast. It breaks the globe, bro.
Matthew, what if that is the case? What if Goldberg says that the pilot is oblivious to it? He can't feel it. It's absolutely completely subtle. You can't feel it at all. But as he's going from the equator with his cruising speed being constant, right? That this, like he's slowing down in terms of the absolute speed relative to the poles. He's slowing down but is just unaware of it as he's traveling north or south.
Why would he be? Yeah. Well, how could he be wouldn't we want the pilot to know everything about what's going on with the plane?
Because
the plane's going to be having to go twice as fast eastward.
That's why.
You want the pilot to know. Wait, if you're out of sync with the Earth, you're going to have a problem.
Yeah, the pilot's absolutely aware of his speed going through the local air, right? He's maintaining his speed going through the air. Like the amount of drag on the plane is the same. The ram pressure going through the Pico tubes is the same. But the only difference is that he's losing momentum without realizing it because like you can't feel that because it's just in lockstep, constantly in lockstep with the Earth.
Not in lockstep. The atmosphere is not sensible. Are you trying to steal? Wait, percentage? Are you trying to steel man their side of the argument now?
Yeah, that's what I'm doing. I'm seeing like what
okay.
That's the only thing that makes sense to me. I think it's unfalsifiable, but that's only
it's just a kinematic concept though, because there's no dynamics to the site.
You keep saying the air is not in lockstep.
There's no mechanics.
You haven't proved that.
There's no mechanics to it.
You haven't told me how much.
Matthew, get in. Matthew's trying to answer it.
The globe claims it's not in lockstep.
How much?
New perspective is not done speaking.
Well, that's what I'm saying. That's the globe claim. The globe claims that the weather systems are caused because it's not in lockstep.
So new perspective. Let me tell you.
I don't know. What is the globe? How much does the globe claim that it's lagging behind? And what is the mechanism that the globe claims?
4 minutes. So
go ahead.
What is that? Okay, wait. Go ahead, Matthew. What's the mechanism that makes it go faster when it gets up high enough, where it has to be moving? Is it a bigger circle, so it has to be moving faster to keep up with Earth? And if it went south towards the equator, what's the mechanism that pushes the plane without the pilot knowing anything, without having any kind of destination, without any path? He's just flying west, southwest against the spin. He's going to land wherever he wants. He's got no path and no destination. What makes the plane go faster eastward backwards, even though the pilot had no idea that the plane's moving faster backwards?
That's a very long question.
Let him answer. Let him answer.
He knows the argument. We've been through this many times, Matthew and I.
Let him answer.
Ahead,
Thank you.
Let's say that there's a plane that takes off at the North Pole and goes straight south towards the equator. Just to give you some numbers, the equator, to a north-south runway. So it's just going straight. And let's say that there's not much wind. That's about 6,000 miles. Planes go 600 miles per hour, so it takes about 10 hours. These are all round numbers, but close enough. And so it has to pick up a sideways momentum equal to about 100 miles an hour every hour. It has to change the sideways, to start moving towards the east, even though it's pointed straight south, which only turns out to be 1.7 miles per hour every minute. So if it's up there traveling 600 miles per hour and at those speeds with all the winds and all the jet streams and stuff like that, that's why I say he wouldn't notice, because 1.7 miles per hour every minute isn't a whole lot. And the thing that causes that might be something like the sideways motion, the increasing sideways motion of the air that is close to the speed of the ground underneath it. So that's the answer. The sideways motion of the air.
That's not the answer. Hold on. Let me critique that, because wait a minute. First of all, he's got no ground path, so he's not correcting for anything. So it's not the pilot making the plane go faster eastward. You're saying that that's not a thing, because pilot doesn't have a destination, right? He could just go towards the equator and land there just as if it's stationary without him correcting for any path or anything. So it's not the plane or the pilot doing anything that corrects for it gradually, incrementally. You're saying that the air incrementally moves the plane, even though there could be winds, heavy winds, the opposite direction. The air is still going to overcome those heavy winds and make the plane move the right amount, even though he only just dealt with the real winds that he could feel and actually measure and see that are affecting his plane. Somehow the plane is still accelerated without the pilot's knowledge whatsoever to be in the 1,000 miles an hour rotation in perfect sync, without any kind of acknowledgement or knowing it. How would you even claim that that's a thing? You're just guessing at it?
Because it's such a tiny amount that it doesn't matter.
Not a tiny amount. It's twice as fast. It adds up.
1.7 miles per hour every minute.
I just looked it up.
Even if you think about it as gradual over time, it doesn't. There's no mechanism to cite that's doing that. And the winds are in the air.
I have the number.
The winds are pushing the opposite direction.
I have the number.
There was no way that you could even detect an acceleration of 1.7 miles per hour every minute. You couldn't even detect that just sitting in a car.
1.7 miles per hour every minute
doesn't make sense. You can, but that's just a mind game where you you make it such a low number over such a short period of time. If you think of it like that, that's not a big deal. But he said, what, 100 miles an hour every what?
Hold on.
Hour?
Let me tell you.
Every
So
hour.
your plane's
Well,
moving 100 miles an hour faster eastward every hour. And you think the pilot has no idea that that's happening?
Right.
Matthew, let's say this plane is going straight
No
south
gauge
from
in
the
the plane saying
pole.
that's happening.
Well, guys, let's say this plane is going straight south from the pole. The pilot wants to fly perpendicular to the equator. Are you saying that if he maintains a heading like due south, that unbeknownst to him, the plane will fly diagonal, like to the equator, and it won't
because
be like
along the ground it'll still be going straight south, but it'll slowly pick up some diagonal speed based on the average wind temperature, average wind speed around him.
Yeah,
So if there's no crosswind, if it's not an issue of wind, he will be blown off course if he maintains a heading of due south, trying to get.
Wait a minute. Wait a minute, Matthew. You said in an hour he's going to be going 100 miles an hour faster eastward. How would that be something the pilot would be unaware of and the plane would have no gauge of? It's going 100 miles an hour within an hour faster eastward.
That's like
no, it's 100 miles an hour in an hour. That's not flight. 100 miles an hour in an hour is not flight. You're saying that there's no gauge that says, okay, now your plane's going faster 100 miles an hour within the first hour. It's going faster eastward. There's nothing the pilot has any awareness of, and there's nothing at all that shows him any kind of sign that happens.
Because it's not measuring its absolute velocity through space. It's measuring speed by wind speed. It measures it with the picotube. It doesn't measure it like your absolute velocity through space. It's measuring how fast you're moving through the air. That's all that it knows.
My question.
So the air is moving the plane 100 miles an hour faster, and you're saying you can't. There's no way to gauge that. There's no way to gauge that.
You got next.
My question to Matthew is, what would be the acceleration curve, the equivalent acceleration curve in a car? Could you just? I can't even think. I can't focus. So what is the acceleration? Let's say you're in a car. What would be the equivalent acceleration? Like say 0 to 60 in a car. And
it is instead of a car just walking. So 1.7 miles per hour is about half the speed of what most people walk. So it'd be like standing up and then over the next 60 seconds, slowly speeding up to be walking about half normal speed. So that's the acceleration.
You'd never be able to feel that in the car, and you would never be able to feel that in a plane.
So I looked up
if I was walking that slow, I would definitely feel that I was going so slow.
Let me give you the atmospheric drag. So in the troposphere, which goes all the way up to 12,000 feet, wind blows all directions. Sometimes it's going with the earth, against the earth. But in general, when you add it all up, all together, the troposphere has a lag. It lags behind the earth. You know how much? 1 to 2%.
Yeah, so it's basically lockstep.
Yep.
I mean, yeah.
So basically, the train analogy works perfect. So when you're going
basically
50 miles an hour in a train,
when you
still 1 to 2% is totally close enough. It's because the wind is way bigger of a factor than that 1 to 2% drag.
There you go. So why wouldn't the wind push the plane way off?
Because they do compensate for wind. Do you think they don't steer and correct according to winds? Of course they do.
Yeah, but you're saying the wind. So you're saying that little bit, right, the winds are way stronger than whatever the Coriolis is. Yeah, that's true. It would be very minimal, whatever the Coriolis force is, which is what you're getting. But we're talking about the rotation of the Earth being twice as fast and the air having to accelerate the plane perfectly twice as fast, even though there's winds going in the opposite direction and he has no path and no destination to correct for. He would have no idea where he is. He's just flying south, right? He gets there. He can always treat it as stationary. There's no correction that he does to stay on course.
There is.
It's just
you're totally unwilling to listen to us. You've talked yourself into this and you're unwilling to listen. So you're just
as he circles the airport, you're saying the air is carrying him 1,000 miles an hour eastward as he does circles forward, 100 miles an hour, just circling the airport, yet an eastward consistency of him being carried with the wind / air in one direction is completely consistent. Too many words. And he goes around in a circle. He's just flying 100 miles an hour in a circle.
There does seem to be a contradiction here. There does seem to be a contradiction here because the effect you guys are talking about, basically, it's the Coriolis effect, right? But the Coriolis effect,
no, it's not the Coriolis effect.
When you're switching, yes, it is. What they're talking about is basically
the Coriolis effect is it would move the plane, it would push the plane westward as he headed towards the equator. The Coriolis force doesn't push them eastward. It would be a westward.
Here's a question.
Okay,
Have you
but
ever
the
flown a
point is
plane?
when you're switching like latitudes from like inertial to non-inertial or what have you, there's going to be a deviation, like a an effect, and it'll make the plane go diagonal when it's meant to be going straight, like perpendicular to the right
Yeah,
to the
that's the
equator.
Sagnac effect, but that's even questionable. I think they're conflating it with the Sagnac effect, and then downgrading it to being less than the winds and saying, oh, there would be no problem because it would be so much less than the winds. Yeah, he would still have to correct for it, so it would be a problem. But because it's so much less than the winds, he doesn't have to worry about it. And that's not. It's not about the Coriolis. It's about the fact that literally.
Okay, well maybe I'm wrong. Maybe I'm wrong. As far as I know, they call it the Coriolis effect. They say it affects planes and ballistics and what have you, anything going north south. And my question is, because they also say the wind like what's the word? The wind. God, I'm blanking on the word.
The wind's dynamic.
Sure, the wind dynamics, but the wind rotation. The wind rotation is also like caused by the Coriolis. So now he's saying he's big tech. You're trying to like separate the wind from the effect of the thing when Coriolis affects the wind. So it doesn't make sense that you would separate.
Yeah, exactly.
Okay,
so the plane just
choose one.
The plane just
the
chooses
thing that
its
creates the dynamics
and its heading.
Hold on, let Big Tech go.
The plane navigates with either maps, and so he's sighting in his topography to choose his location. He's got a compass and he's got topographical readings, or he's got a GPS that tells him where he is, and he just chooses his heading, maintains the heading, chooses his airspeed, chooses his altitude, and just locks that in, whatever it takes. And if he has to steer a little left, steer a little right, he just keeps it locked in on that. And then when it's time to land, he just finds the approach path for the airport, and then he makes
now you're saying if there was hold on, Big Tech, say there was an emergency, right? He has no ground path. Like I was saying, kamikaze pilot he's flying wherever he wants. He's going to find a spot to land. There's no destination. Are you saying in that case he'd have a problem with being in sync with the Earth?
I don't get what the kamikaze pilots pilot
no,
themselves into a
there's
ship.
no ground path. If you had an emergency, you lost all communication with your ground control, you've got something wrong with the plane, you're just flying, right? You're saying without a destination, there's a chance the pilot would be out of sync with the Earth by the time he gets there? Because now you're claiming the destination.
What do you mean he'd be lost? Yeah, if he didn't have any headings, he'd be lost.
No, not talking about lost. They're talking about being in sync with the Earth. You're saying the destination makes the plane move faster eastward. That's what you're saying.
Let me get in.
That's what you said.
Okay.
No, dude.
He steers and he corrects.
2 points.
Making the plane
that's
go.
How he gets where he's going, and then but
if it was a moving Earth, it's a moving Earth. This is what the baller.
But he's in a moving air system. He's in an air system that's moving with the Earth.
The air system has winds going the opposite direction.
No, it doesn't.
New perspective.
It does. Winds going all directions.
I think the reason
so all directions, not opposite directions. It's
stop cutting in. I'm trying to get this figured out with Big Tech. Big Tech, the wind's going all directions. That's
hold on. It isn't just one-on-one.
It's not going one direction.
If you guys want to do it one-on-one, we could set that up. But it's
so since it goes all directions, it's not going opposite directions. It's going all directions.
Okay. So how do you know that it's going to move the plane in one direction perfectly?
Well, whatever the wind condition in his location, he compensates for that.
Let's compensates. He's got no destination. Because he isn't compensated.
Well, if he's got no destinations, then he'll end up anywhere.
Yeah, but the problem is you're saying the destination is what makes the plane go in sync.
I'm going to get in.
Even if he's lost, he's got to be in sync with the Earth.
Let the other guy go.
Even if he's lost, he's got to be in sync with the Earth.
Big Tech's leaving some space for you. Go ahead, Red Cloud.
Thank you very much. I appreciate it because I'll just forget it and I can't stand that. It'll bug me. Thank you. Okay. Thank you. Oh, goodness.
Did you forget it?
All right. I've got it. If you've ever flown a plane, I have twice. That's the first point. I'm going to go to my second point, then go back to my first. If you have a drone and you set it to fly a certain course, you can program drones to fly a certain course, or you can program them to just stay flying in one particular spot.
Yeah, hover mode.
No matter what the wind is doing, the drone will fly through the wind and take that path. That's what planes do. Back to my first point.
But did you wait? You're ignoring what I just said. There's no path. There's no destination. No GPS.
New perspective.
No GPS. That's my argument. But hold on, wait. You have to include my argument, right, Kyle? We've been through this before too. There's no destination. He's just going south. So there's no like
just let him
aiming or
finish his point, and then
correcting
you
that's
can
gonna
respond.
happen.
New perspective, calm down.
Okay.
We're all passionate about this because
Go ahead, I'm listening.
I want to just say real quick before
I need to
Red
get to my
finishes
first
his
point.
point. Yeah, you'll go back to your first point about you being a pilot. Absolutely. I'm just saying, like, I think the reason why we're passionate about this and we like there's so much confusion regarding it is because so far we haven't been provided with like a clear, succinct, sensible answer.
Yeah.
That's how it feels.
Right. Because it's always been really, really vague. No one's ever said, if we fly from this airport to this airport, right, what would that? No, everyone's just getting these always sort of very, very well.
Well, we tried. Go ahead, go back to your point about being a pilot and flying.
You understand now?
Okay.
Red Cloud, you understand why I made that?
Let me. No, because you're not steel manning the globe.
Go ahead, just get back to your point.
Real quick, Red Cloud. The reason I included.
No, wait. Just like let him finish his point, man. Then you can answer it like substantively.
All right.
If you've ever flown a plane, thank you. Perspective. If you've ever flown a plane, okay, I'm not saying I'm a pilot. I've in 2 separate occasions flown 2 different planes. Okay, on both occasions, there was a little bit of side wind. It's a little freaky. Okay, when you're in a little plane, it's a bit scary, but I managed to do it because I'm a big boy. And when you're flying, you're trying to aim straight, and there's a side wind. You turn the plane turns slightly. If there's a wind, so you're actually looking out of a different part of the window. Okay, that's when you fly. That's how a plane will fly, regardless of what else is going on. It does a heading. So regardless of what the wind is doing, the plane will fly straight. That's why I mentioned the drone. It'll do the same thing. Okay, so you can't. I think what you're trying to do is trying to introduce other things. Like no GPS.
No,
and
skip the guessing what his argument's going to be, like, because then it just leads to straw mans. Go ahead.
Yeah, Red Cloud. Let me respond to that real quick. For a second. Yeah, Red Cloud. The reason I included no GPS, no destination, no ground path is because that's how you try to get out of this argument. Is saying he just corrects for the ground path and he gets to the destination. So because he's at that destination, he must be also going 1,000 miles an hour with the rotation because he's at the destination. And he corrected for it, meaning that whatever he did with his plane to overcome the effects of the winds and the rotation, it got him there. And so then, therefore, the plane must have accelerated without the pilot's knowledge, and that's incremental, so you would never notice it and all these things. No, you know that he could just fly without ground path, without GPS, go south, and always land on it as if it's stationary, right? No matter what.
No.
Well, hold up, he's right.
Okay, so
in so much that when you mention your hover, when you mention the hover, a mode for the drone, that's relying on GPS and stuff like that, and it's a red herring.
I'm saying if somehow I agree with you. If you launched from the north and flew south, and you flew straight south with no heading, no navigation, right? So no topographical landmarks,
you're not aiming.
No change.
Well, you have a heading. You're heading south, but no GPS.
You're just heading south, but no navigating.
Oh,
right? You're just following your compass. So if you just follow those of the compass, and so when you take off, you're going to be aiming at one location, and when you get down there, you're going to miss it.
Right. Now we have to walk through the logic of that because we talked about this in the very beginning. That's saying that the Earth moved east to west, right? As the plane was flying dead reckoning south, meaning that the pilot could put a camera out the window and show there's a perpendicular movement of the ground below him rotating east to west, and we wouldn't be having this talk any longer.
No, you just messed up.
A long time ago.
You just destroyed it.
It would be. What do you mean? No, you said he would miss the destination
you have to somehow,
because the destination would be further east. The destination would be further east, is what you're saying.
Yeah, but the camera wouldn't show that.
If he goes dead reckoning. Well,
the camera should show it
separately. It would.
Because what would the camera show?
Because if the camera doesn't show it, then basically what you're talking about could be explained by crosswind.
Well, I mean, we're imagining a scenario where he follows the compass and there's no crosswinds. We're imagining we're removing factors.
Yeah.
Right?
So
if we had an imaginary world that didn't have crosswinds and didn't have currents, and he could just maintain a south heading without having to do any type of correction.
Yeah.
You're saying you would fly down
camera on the bottom of the plane.
Then he would miss the place.
Camera the whole way.
Then he would land somewhere other than where he was aiming.
He had the best, he had cameras all over the plane, pointed straight at the ground, right? And he's headed dead reckoning south. that means those cameras would pick up the rotation eastward because the plane's not in perfect sync with the Earth. That's the reason that there would be a deviation.
Yeah,
because
totally. If the air wasn't
So we
affecting
could
him at
prove the
all.
Earth rotates just right there. Be easy enough to prove the Earth
air
rotates.
didn't affect his
I think we all agree
plane,
on this. This is where the disagreement is. This is where the contention is. This is the crux.
the air didn't affect
He's saying
Coriolis.
going straight south with no wind. The wind is like, we'll have it a constant. That they'll fly a diagonal path and they'll miss their perpendicular destination due south. Whereas new perspective in flat earthers' stance is that if you go straight south and wind is not an issue, then you're just gonna hit the perpendicular, like hit the equator perpendicularly, and you're not gonna miss your, that location.
Yeah, this could prove the Earth rotates or not rotates very easily. Even if there were winds, you could say, well, we have this much wind, but I'm still staying in my dead reckoning south path, right? So the Earth has to move east to west underneath me for me to miss my destination.
The issue is they say the Coriolis causes the wind
1 to 2% off.
So you can't separate the winds out of it.
If he was in a Cessna, if he stayed below 12,000 feet and he flew that whole path, he'd be 1 to 2% off.
No, dude. Listen, if it started, it's still twice as fast. The plane has to be moving twice as fast eastward from 500 to 1,000. There's no mechanism that does that. Pilot doesn't do it.
The air does that.
The air does that. The wind goes in all directions, bro. Air pushing the plane is a wind.
It goes in all directions, but it generally goes in lockstep with the Earth minus the 1 to 2%.
But how can you say generally? How can you say generally in one direction, but then some days there's a lot heavier winds westward? So why wouldn't that mess up your
winds are
general?
pressure systems, man.
That's because
it has
it's
nothing to do with lockstep.
So it doesn't matter. The plane has to be in perfect lockstep.
Oh my God, dude.
There would be so many variables.
Your mind can't comprehend the variables or something. The wind is pressure systems.
Your mind can't comprehend how dangerous this would be if Earth were turning.
No, the wind is pressure systems. The lockstep is a difference of 1 to 2%. Overall, when you add them all up, you get a 1 to 2% difference.
You're conflating it. You're saying that 1 to 2% at 1,000 miles an hour. It's still faster than where the plane took off from. If you're going to claim the conserved momentum is keeping the helicopter in sync with the Earth when he takes off because it was on the ground, now you have to come up with another mechanism that keeps it up with the Earth as it goes south towards the equator. It's not a matter of 1 to 2%.
Yeah, it's the air. That's the mechanism. The air.
No, the air. That's what I'm saying. That's your only concept that can get you there.
That's all you need. All you need is the air, dude. It's an airplane.
You got air. Air pushing the plane is a wind. You got winds going all directions.
No, wind is the difference between airspeed and ground.
The wind
is caused by the Coriolis. That's why they say the air goes in generally one direction. The Coriolis is causing it to go in one direction.
Can I have a moment to annoy
no dynamics?
Bro, yeah, go ahead.
May I have a moment to annoy new perspective? I think, man, you're not steel
air pushing the plane is a wind.
You're not.
Yeah, you need to steel man our position and say what you think we're saying.
What you need to do is.
I'll do that. I'll do that. I'll steel man it. Now, in my scenario, the pilot has no.
Hold on, you guys.
Let me steel man it.
You guys, you've got to go one at a time. Hold on for a second. Can you guys hear me? You guys got to go. This is complete audio chaos. You got to go one at a time. Even earlier, like Percentage and New Perspective completely talked at the same time. Couldn't hear either. Can we maybe slow down so we can hear what you guys are saying and maybe go one at a time, please? Because I just got back. I just unmuted, heard it, and it's like, whoa! It's just complete. Like, yeah. Let's just try to go one at a time.
My fault. In fact, I've probably been overzealous, like I usually am with this argument.
Thank you. All right,
but yeah, I'll steel man it.
Bless you,
I was asked to steel man it. I was asked to steel man it, right? So the pilot has no direction, no destination or whatever. He's just flying south, dead reckoning. That's all he knows is he's going towards the south. And he's got, he's got to be in sync with the Earth. But the air, even though there's winds going in all directions, the air carries the plane and accelerates it incrementally as he reaches those higher latitudes where he's going to have to be in sync with the Earth. And even though the atmosphere is not in sync, which is what creates the winds that were also pushing him off course, or even though he didn't have a course, the winds were pushing him in all directions.
This is a terrible steel man. Start over. I reject
it
already.
The air carried the plane.
You failed.
The air carried the plane faster, twice as fast sideways, is what you're saying.
No, that was a terrible. You've put in a bunch of bad things with the steel man. Steel man's supposed to say our perspective the way we think it. Is that what you think we're saying?
You're saying that the winds don't matter because the air still carries the plane twice as fast sideways.
That is the wind doing that.
Yeah,
So
like
of course the wind matters.
a steel
It's not
man.
carrying it
Well,
faster.
no, it's not wind. No, wind is difference
and it's
between
not-
airspeed and ground speed.
Yeah,
Well, you have
it's
to make that. You have
it's
to
not
make that
carrying it
distinction. If the
faster.
air pushes the plane faster sideways, which it would have to do, then
Yes.
air pushing the plane would have to be a wind that's not a wind.
No, it's right. It's not a wind.
Okay, how does it work
It's
then? How does it push the plane sideways faster?
It's the air is the medium, and it's rotating with the Earth plus or minus 1 to 2%. 1 to 2% difference in drag.
So how does it accelerate the plane?
So since the air is flying, since the plane is flying through the air, and the air is going with the Earth, the plane is going with the Earth.
Right, but that's just a concept, right? You have no force, you have no dynamics to it whatsoever. Because the dynamics are the real winds pushing the plane the opposite direction.
What
There's no wind pushing the plane in the opposite direction.
Could be.
We
Could
have
be westward winds all day long. Heavy westward
could be
winds.
winds pushing it in the. It could be pushing you with it too.
Right. So how do you know the difference?
Well, we do.
You don't.
Have
You just
years-
adjust for whatever the local wind condition is.
Yeah, but what are you adjusting for if you have no ground path? You have no path, that you have no destination. You're just getting
That's
there.
what navigating
and your plane is going to be moved. No, I'm not talking about navigation. That's why I make the scenario. He's got no destination. He's got no path. He's just going south. But you know that the plane is still going to be in sync with the Earth. He's never going to have a problem being out of sync with the Earth when he
Both
lands.
scenarios have been answered. Both scenarios have been answered.
Here,
both
different
scenarios
scenario.
have not been answered.
Here's the
You can think
here's
of
the answer.
air
The
moving the
answer's like
plane
this.
without it being a wind. You can
The
think of it
answer's
that
like
way.
this.
That's just a kinematic concept. There's no dynamics.
Let me go. So the boat leaves its dock and it's sailing across the river, and it's the Mississippi River, and it's in a wide spot, and the water in the water in the river is flowing south toward the Gulf.
How fast?
It's going at 5 knots.
Okay.
The boat takes off with a heading going due east from the West Bank.
What's the name of the boat? Sorry.
It's called
Go ahead.
the Dixie.
All right.
Well, it's called Old Dixie. So Old Dixie takes off from the boat dock going due east from the West Bank, and it's sailing across the river. And it just points due east the whole time. It never deviates from pointing east. Does it hit the dock, or does it hit a little down the stream?
Me, pick me.
What's your comparison? Was that a comparison to the wind moving it?
It's a perfect comparison because the medium that the boat's traveling in is the water, and the medium that the airplane's traveling in is the air. It works
It's not a
exactly
perfect
the
comparison,
same way.
though, because
Big Tech, I know the
currents,
answer.
right? Listen, currents in the river, right, are comparable to winds in the air.
No,
That's what they're comparable to, right? And we
Nope.
don't have currents pushing the boat upstream. That'd be the westward winds pushing it in the opposite direction. You don't have that. You have the current of the water going in one direction. You may have little jetties that go
I already
maybe a
said
little
no.
bit sideways. Well, but your comparison is non sequitur. You've got
it's not.
viscosity. You're never get the
Perfect
water.
comparison.
You treat
You
the
just need to
earth
think
as
about it.
stationary. You're not treating the bank when you're moving in a river. You're not treating it as stationary. You know
Yeah,
you're
the
moving.
boat docks are stationary.
train the pilot-
They're not moving.
You train the pilot to compensate for that one direction, right? You're not training the pilot to compensate for the rotation.
He just has to
That's what
compensate.
navigation does.
That's what
He's
navigating
not
is.
compensating. No, there's no navigation. There's no ground path. There's no destination.
Well, then he misses the target,
still-
dude. If he doesn't navigate,
but
he
he
lands wherever
doesn't
the
matter
wind
if he
blows. He
misses the
literally
target or
lands
not.
wherever the wind blows if he doesn't navigate.
Right, and he lands as if it's stationary still. That
No,
means
you're
that
just
there's no
saying that.
rotation compensation.
I
So you're
realize
saying that there's a chance
I
the
realize
pilot would have to deal with a rotating Earth to land on ever? You're saying that's a chance?
No,
He would have to
he's
sink the
going.
plane
He's in air that's
land at-
rotating with the Earth, my dog.
No, I'm
On
saying so.
every
That's what
flight,
you're
you'd have
saying.
to
It's not about the
compensate.
ground path to the destination at all. You're saying it's
On
just
every-
due to the air, and
on
the
every
air pushing the
flight,
plane
you'd
is a wind, and wind's going all
On every-
directions, so it falls flat on its face.
On every flight, the plane has to correct. That's what Coriolis is. That's what Coriolis does.
No
it
destination.
deviates
No
the
correction.
plane.
No correction.
If you don't
He's not
have a
correcting for anything.
destination,
He's got no ground path.
your direct south path will deviate. If you do have a destination, then you're navigating, and then you can quite easily. And there's no problem.
There's no
because the
destination.
plane
So you guys go
changes
back and forth between saying it's following the ground path and correcting for that makes it go faster.
I can't
And then if I say there's no ground path, you say it's the air that does it.
Well, you've got your
Respect,
answer.
you just trample
What's
all over
happening
him.
right now is
Let him
you're not
finish.
accepting the answer.
Yes.
You're not accepting the
No,
answer.
I'm pointing out that it's a kinematic concept only. It's only a kinematic concept because there's no dynamic forces to designate whatsoever. You can't identify any kind. It's a total violation of the laws of conservation of energy and momentum. You can't have the plane going faster without a mechanism and make the plane go faster. That's recognizable and detectable. It's just a concept.
Yeah, that's not a. I'll say it in this way. That's not a representation of the globe. Well, that is not a steel man of the globe.
Yeah, you did not.
Well, the steel man needs to name the mechanism. Well, steel man the globe yourself. You can't name the mechanism either. You just have the concept of the air making it in sync, even though the air is not in sync itself, and it's got winds going in all directions.
Except for a 1 to 2% difference.
Yeah.
Regardless, you've got winds going in the air the opposite direction, also pushing the plane. When you know it,
we know how it compensates for that because it's got propellers.
He's not compensating. Why would he have to compensate? He's letting the pilot's letting the air move him wherever. Wait, he's got no compensation because the pilot's letting the air move wherever the air moves him.
So we've already answered that a bunch of times, dude. You're just not accepting the answer.
The thing is,
you're saying that the winds. You're saying mathematically it works out. Conceptually, I can steel man it. It's just a kinematic concept that whatever it needs to be increased eastward, we're going to take that. We're also going to minus all the winds that happen to go in the opposite direction at different unpredictable speeds each day. We're going to subtract those, and we're going to say it still moves the right amount exactly eastward, even though there's no mechanism, even though the winds were heavier one day and not the other day. It still moved the plane perfectly the right amount to be moving eastward faster so it could treat the Earth as stationary, even though the pilot would sometimes have to be, the plane itself would have to be carried backwards as it lands facing westwards. It'd have to be carried backwards at 1,000 miles an hour, even as it slows down to 100 miles an hour.
We're looping. You're not accepting any of our answers, and you're just ignoring us. So
I'm pointing out that there's a complete contradiction of the laws of conservation and momentum and energy.
I propose we move on because we're being ignored.
If we did have this conversation,
I've been through this many times. We can stop. But I'm just showing that there's no.
I have a subject that we can move on to.
You guys want to move on, but Red Cloud's still trying to get his piece in.
Yeah, and then let's just maybe slow down again just to finish. Okay, Red Cloud, where you're gonna go, but let me just say one thing. Well, okay, I was just gonna say just the quick thing is just with this whole thing. It's just an open question. Somebody could answer if they want. I'm just gonna say it, and then I'll pass the mic to you. Then, if someone wants to answer my thing, they can.
Thank you.
Simply, can you in any way replicate air moving with something like a moving surface or a spinning sphere or anything like that? Replicate this of the air, this effect of physics that's being claimed of the air moving along with this globe and then creating, I kind of call it like jello, like if you were to imagine a ball that has like jello on the outside of it, and then as you spin the ball, the jello would go with it. And so if you were an airplane in the jello, you would kind of go along with the ball in theory, but like we don't live in jello. So what is the mechanism, if it's not jello, that is creating that, and can you replicate it in any fashion?
A drone flying in a moving train that's speeding up.
If we did discuss this, I recommend either party, or whatever party, big tech specifically, I'm going to speak to you. But if we did discuss this again, I think we should not discuss this again until we're a very, very specific scenario. Pick an airport, pick a plane, and pick a destination airport.
So you need your ground path. And then we can talk about you need your destination. So you can say he's correcting for the ground path, and that answers it for you.
Nope.
But that's not the truth.
Going back to it.
It wouldn't.
Not going back to it.
You don't need that.
You're arguing it again. I'm not arguing it again. I'm just saying if we did discuss this again, get down to specifics, because this is too in the air.
Too vague.
Because
but you can't just say if we. You can't just say if we discuss it. But hey, I'm going to throw a point out, but you can't respond. At least let them respond to the point.
Yeah, exactly.
Okay, fair enough. I mean, Gio, all right. But I didn't want to get back into the argument because that's what it felt like it was.
So if the Jello atmosphere pushes the plane in one direction, right, and it somehow pushes it only in one direction, then the pilot couldn't fly against the spin because the Jello is trying to keep him in sync with the Earth. You wouldn't be able to fly west southwest against it, and then have the Jello also moving him faster eastward towards the sideways.
No, you could have that. You could have it because when you change your speed in the Jello, that's like relative to the Jello, which is also relative to the ground. But I mean, you could fly backwards in the Jello if you wanted, and you would still be. But you'd have to make an analogy that you're propelling off the Jello as well.
Yeah, a boat can
Like
accelerate
the
up
forces
river.
on the plane. The pilot's aware of the forces on the plane. If there was a force pushing his plane backwards and sideways at 1,000 miles an hour as he's landing, slowing down, he would know there's a force pushing a plane or carrying the plane. You can't just say, "Oh, well, it just would be something that would be so slight that he would not be aware of it." No, there's a force pushing your plane 1,000 miles an hour backwards as you're landing and slowing down to 0 forwards. You're going to know there's a force that's on your plane doing that.
Oh my God.
Yo, Gio, give me 1 minute. I'll give you a demonstration. Like, hold up, Gio asked for a demonstration. If you guys give me 1 minute, I think I have like an adequate demonstration. All right.
Well, the only one I've seen, I mean, you can have like a magnet, like a spherical magnet, and then you can drip ferrofluid on it, and then you have ferrofluid that is clung to the spherical magnet. It's like the closest I've ever seen to the idea of replicating this idea of like the globe Earth with the atmosphere that kind of goes along with it and all that is like ferrofluid. And it doesn't really work like the globe does per se though, because if you start spinning the ball, the ferrofluid like takes a minute to catch up, and then it starts spinning. You know, it's like separate. It's as you would imagine. It's not like perfectly synced with it. Even if you get it going at a certain rate, it just doesn't really fit.
Like the blender. You know, how about like the blender doesn't work because in the blender you only have everything moving one direction. You don't have things going like a cherry going the opposite direction of the way the blender's moving it. That never happens.
Yeah, let me give you my thought experiment / like demonstration. It's not going to be like feasible. Like it's not that super realistic. It'll be very expensive to do. But imagine you had like like at the airport how you have like those conveyor belt / like escalator type things, or like kind of like a treadmill. You have this moving ground basically. Imagine you had rows of moving ground successively getting faster and faster, but it's the disparity between them is like imperceivable to your proprioceptive senses, right? And let's say this warehouse is pitch black, you can't see, and you're running, right? So you're running, and each step is another conveyor belt, and it's just like very, very negligibly getting quicker, right?
Right. One conveyor belt's going 10 miles an hour. The next one's going 10 and a half.
It's a very wide belt. So even though you're going sideways, you're speeding up as you're running on these conveyor belts. You get to the end, you're a lot faster than you're going a lot faster sideways than you realized, and you're kind of not perceiving each step that you're taking.
But you know that's a non sequitur because it's in one reference frame and you're actually on the ground walking with it relative to you're right there. It's different. When you're in the air, you're in a separate reference frame. You have to have that, whatever that force is that the conveyor belt would work on, pushing your plane one direction. And we also have wind.
Absolutely. That's why when you're in the air, if the conveyor belt is going, if the conveyor belt is going too quick enough, then as you land from being in the air, you'll feel it. You'll feel like, oh, there's a disparity in the speed that you were in the air versus the like when you hit your foot on the thing. But I'm saying it's so negligible. This is what their claim is. It's so like you can't even feel it. The pilot doesn't feel it. Right, so your body just like can account for it without you realizing. Like those those restaurants that are on like ferries they're spinning, and it's spinning so slowly that you can't realize that when after you had your meal that you did a full revolution.
That's how they have to think about it, but still a non sequitur because you're on the ground walking across the moving room or whatever, and you're not going to notice it as much because you're on the ground in the same reference frame. If you're in a separate reference frame, you would have to have a mechanism that keeps you up in perfect sync gradually, which they don't have, because that mechanism they try to name has winds going in the opposite direction. Like if you had conveyor belts going in the opposite direction as you're walking across that floor, that would mess it all up because you have some forces moving you in the opposite direction as you're walking across it. So it's a non sequitur.
That's why the river doesn't think it is. I think each step would be a new reference frame. Each step, it's like a new speed. It's a new reference frame, just barely,
Right, but you don't have parts of the conveyor belt going in the opposite direction.
It doesn't need to be to be a different reference frame. It doesn't have to be the opposite direction.
No, but to compare it to the air, the atmosphere, it would need to be because you have winds in the air pushing you in the opposite direction.
I know. I'm not making a perfect kind of like parallel.
That's why it's an analogy.
If the analogy was perfect in every respect, it wouldn't be an analogy. It would just be the damn thing, right?
But that's why the analogy doesn't work because it's completely different without the opposite direction of the winds.
I don't know what you seem like you act like I've been listening and it sounds like you're pretending like you don't understand what we're saying. There is no opposite direction of wind.
That's why we asked for
what
the
are you
steel man.
What are you talking about? There's no opposite direction of wind.
Winds go in all directions, right?
Yes. Yeah, we're being so
then you're saying that
we should just be going like doy.
There's a special wind that pushes the plane one direction only to keep it going faster eastward. There's a special wind, even though there's other winds, real winds, pushing them in all directions. That's what I'm saying.
I picked the wrong day to quit, man.
Gio, what did you think of my concept? My what's the word I'm looking for? Demonstration.
Scholars have said that a lot. Like, what if you're in like a restaurant that rotates? You could walk across the floor and you wouldn't even notice it. It's non sequitur.
They have those
opposite. Yeah, but you don't have opposite. You don't have parts of the floor moving in the opposite direction.
They don't
have the way the wind move you in the opposite direction.
Hey, can you?
Because they're saying the wind pushes you in one direction.
Hold on, can you hear me?
Yeah, we got you.
Yes, we can.
Okay, I don't know if my mic wasn't coming through before. I had to leave and come back. Did you guys not hear me before?
No, we didn't.
We couldn't hear you before.
All right. Okay, well, just give me like 20, 30 seconds. Let me just respond to percentage. And then I was just going to say one thing from before is, well, they call it like an air mass, like the mass of air that's kind of with the globe. And then you would have the other wind variations within that, 5 mile an hour wind from the left, right. And that would alter it a little, but they kind of refer to it as like the mass of wind in a sense, the air mass that's going along. But that's, but I'm not trying to. But okay, that was just from one thing from before. And then percentage, what you were saying, yeah, dude, I mean, that is kind of the idea in a way, and that is kind of how it would work on a sphere in some ways, like even outside of a globe. But if you just, like, not a globe Earth, but I'm just saying if you had a sphere where the speed, is going to change, because obviously, like, if you're going 1,000 miles an hour at the equator, by the time you get to the pole, you're going 0. In terms of the rotation. So there has to be obviously all the, but yeah, what you were saying with the conveyor belt kind of thing, or like the walkways. Yeah, that is interesting. I mean, and Kosho has that animation. Have you seen the one he's made that shows the ball going and then all of the, it's kind of like that too. Because yeah, if you were to have like a one of those walkway things going 5 miles an hour, the next one's going 5.5, the next one's going 6, the next one's going 6.5, next one's going 7. Maybe if it's only half a mile per hour, whenever you walk, if you were just walking on them, and let's say each step was a new conveyor belt, so you put your foot to the right, you're on one foot to the left, or even if you walked on the belt for 3 steps and then go to the next belt for 3 steps, whatever the case may be, yeah, if the speed was very minimal between them, then yeah, conceivably you wouldn't even notice that you're actually, speeding up to much faster. Now you'd have air friction and stuff like that from the air, but I mean, removing that kind of thing, I mean, in theory, I mean, you'd still be moving, but yeah, you'd be able to increase speed in a way where you're going like, quite fast, but you didn't really make any additional effort. You just kept taking normal steps.
Hey, Gio, do you understand why I was saying it's non-sequitur?
Forward the same speed, but laterally you're going faster.
But still, even though you agreed that it was a non-sequitur because you don't have the ground moving in the opposite direction, making that adjustment, doesn't matter. There's no ground, there's no destination. You've got winds going in the opposite direction, heavier one day and lighter another day. Yet the air mass concept still moves at the same exact amount eastward to be in sync.
Dave, honestly, I don't think
so. There's all these variables. It is a non sequitur if you had like some of the runways going like in your idea of the conveyor belts. If you had some conveyor belts stronger that were going the opposite direction than the other conveyor belts, that would be a totally different thing. Which is what the winds would be if there were westward winds messing up the eastward movement of this air mass, accelerating the plane perfectly the right amount eastward only.
Well, I guess the analogy might be like if the air mass was the conveyor belts, Let's see if this will work. I'm just coming up with it on the fly. If the air mass was the analogy of the conveyor belts, you walking on the conveyor belts is like the airplane. So you have some thrust because you're moving right foot, right foot. That's like the thrust of the airplane in the analogy. You're walking along the conveyor belts, and then if you also had a wind, like a 10-mile-an-hour wind from the left or if you had a 10-mile headwind or whatever, like even though you're walking with it and doing that, that would be an additional 10 miles an hour. So you might have to you might have to walk a little harder or turn up the thrusters on the plane or whatever. Or if you had a 10-mile-an-hour backwind, either a headwind or a tailwind, or if you had from the left and right, there would be that adjustments in it. Now, I'm not really making this argument as saying it's valid because, there is this idea of the air mass that goes with the globe. That's why I asked, is there any way to replicate it, or has anyone seen or thought of any way? And so on, yeah.
Conceptually, we can think of it working. It's not like we can't steelman the concept. It's just there's no dynamics and there's no forces and it doesn't work. And you're talking about a plane having to be exactly twice as fast so it can treat the Earth as stationary. That's the reality of it. Now, the mechanism that does that also compensates for the winds moving in the opposite direction, which could vary on any day, being stronger one way or the other. And if he's got no destination, no ground path to correct for, you can't say it's the pilot doing anything. So when he gets to the area that he decides to land in, the plane's going to be moving at 1,000 miles an hour faster, or the stationary ground's just not going to be moving at all, just like he can always rely on treating it as stationary. That's the only way it would work. You can't have all these variables, just like estimations, like pretty much in sync. The atmosphere is what's supposed to create the dynamic system. Then
well, it sounds like, hold on,
the dynamic system statically. But you understand what I'm saying, Gio, about their claim is that the difference in the atmosphere to the ground is what creates the system, the dynamic system. But then they're also saying that same atmosphere carries the system in a static relationship to the ground that it's already not in sync with. So it's a violation of conservation of momentum and energy and anything common sense.
No.
Yeah. So keeping up with the thought experiment, right?
That was so many points, dude. It broke the flow. I wanted to respond to the first 5 points, so
really
I guess
just
we'll just
I'm sorry, I'll shut up. But
You have to write stuff down.
I have a quick thing for Gio.
Just 1 point at a time at the minimum or something, just because I don't.
Yeah, I'll try to keep it concise. So if keeping up with this, like walking on the walking paths analogy or what have you, let's say yes, you're thrusting forward, going forward, right, and the successively or minimally, negligibly moving faster things are moving you laterally, right, faster and faster without you knowing, and if a wind like a gust of wind does come, then you can account for it separately. Like it would make sense to me. Like, I mean, I could understand how they would treat them separately. Like, either way, you're still moving faster, laterally, but that speed might be affected by winds, like a 10 mile per hour wind or something like that, which you can register and account for as a separate system. You can have two separate systems. You understand? What do you think?
but to also I hear what you're saying for sure. But to link back to what one of the points New Perspective was saying is that the thing is like, I mean, what I was going to say originally, I think to him too, and then I'll link into what you were saying, is that like really it sounds like his argument is more like the mechanism that's claimed for why this works on the globe to where it can function essentially as stationary, but it's supposed to be a spinning globe. That mechanism is faulty. Because when you say it in the way like it can't happen on a globe, well, if that mechanism was there, then it could happen on a globe. So it's really like, sounds like your argument is more in the mechanism not being there. Because I don't think it's there either. Like, well, hold on, let me finish. I don't think it's there either in terms of meaning. I don't think we're on a spinning ball with an air mass that functions in that way, and it links back to some of like water sticking to a ball, their claim of gravity, many other factors that are kind of parallel or ancillary related to this. So I'm not saying that is happening. So I hear you. Like, I agree with that argument. Like that the mechanism for that would have to be validated, because I don't think that's happening. I think we have a stationary planar Earth, and then the atmosphere, as we would call it, or whatever term we would use, the air, everything just is as it is. You're moving through as the air is flowing. So, I mean, percentage, I hear what you're saying. Like, there's not an issue if that mechanism is there. If you can have a huge air mass that is, we know the way air is. You can swipe it back and forth. It doesn't just go with you in that way. I mean, you have like Bernoulli's principle and vortexes and stuff, but I mean, we don't really have a mechanism. That's what I was saying before. Like, could you in any way replicate a globe with an atmosphere that does this, or a sphere in any way? Now they might say, no, it has to be big. So now you get into this scaling thing, which some could maybe even call a scaling fallacy. Oh, it has to be so huge in order to do that. That you can't really do it other than just the Earth itself, and then you can't really go to space and check it, and then you get into that whole thing. Because that's kind of part of their claim of why the air moves along with it, and some of the components of that, which gravity is one part, because you have the whole thing being pulled to the center, the whole mass, and then you have the gradient and everything, which is going to be related to that too.
Gio, don't you think the plane would be the perfect thing to detect that mechanism? Like if the plane is being literally accelerated twice as fast by the time it gets there, and then there should be something that the pilot or the plane or the gauge or some kind of accelerometer on the wing or something would be able to know, yeah, you moved faster eastward, even though you maybe didn't notice it, but there was a force moving you eastward faster, and it'd be detectable, and we'd know about it. There wouldn't be any kind of guessing on people on YouTube trying to figure this out. There would just be an answer you could look up, and you'd know exactly what it is.
Your perspective, I just want some numbers for you. Let me jump in.
It would be circular logic because they maintain that this happens on the plane, and that's what's in dispute, right? So
I just did some math
sense to go
to put this in perspective, and I think this will be helpful. So using ChatGPT, which is really helpful for this type of problem, I asked it, at what latitude is the Earth rotating 500 miles per hour? Because we know the equator is going 1,000 approximately. It tells me 72 degrees. It's going 500 miles an hour. And then I said, how many miles is it linearly from that latitude to the equator? And it gave me a number of approximately 5,000 miles. So it's about 5,000 miles from the equator. You're going half as fast. And I think this is pretty good because now we can go, all right, so if you were flying straight south from 72.6 degrees latitude, going to the equator at 90, then you would have to go, for every 10 miles you fly, you'd have to accelerate 1 mile per hour in order to match the speed. For every 10 miles you fly, you have to speed up a mile an hour.
Does a pilot do that?
Nice. So there's your conveyor belt. There's your conveyor belts. That would be your, because remember I was saying like a half mile an hour in my example. So yeah, if you're saying 1 and you're saying over 10 miles, so that'd be again, the mechanism would have to be there. But if the mechanism was there, like you could make this mechanism on a video game, which you can. Like there's games that do this, like Mario and whatever, different games where you're on spheres and you can fly planes around and you don't really have to like accelerate more per se, because if the whole thing is going with the sphere, then it's like it's stationary, meaning you don't really have to. That's the whole thing. Is like it makes
so the dynamic force.
They're going with.
So the dynamic force is that I'm saying that air that's rotating with the Earth is adding air pressure onto the cabin to the degree of 1 mile per hour of acceleration per 10 miles that it flies.
Right, but that would be the thing is that mechanism is not identifiable. You got winds pushing it in the opposite direction. The pilot could be aimed west-southwest against the spin, right? So now you have to imagine this air pushing the plane backwards 1 mile an hour or 100 miles an hour every hour.
Okay, I agree with everything you're going to say. You don't have to say it. You've already said it so many times. I totally get what you're going to say. So the thing is, what you're asking me for is basically you're making an unfalsifiable claim because you're saying, oh, because the winds blow here and there, you can't measure that. Exactly. So what we understand is this is what's at work and it makes sense to us. And you're going, but you can't demonstrate it. It's like, well, it's an unfalsifiable claim that you're making, which is that they navigate in a non-rotating flat plane. And my proof is this thing that you can't test.
Well, yeah, but you're making an unfalsifiable claim that the mechanism is there. You're saying the mechanism is there, but the pilot can't notice it and can't detect it and can't have any kind of gauge. There's no detection whatsoever of that mechanism. You're making an unfalsifiable claim.
Your claim is that what they're doing violates the laws of physics, and you're making an unfalsifiable claim.
No, because there has to be a mechanism to match the laws of physics.
Yeah, I'm claiming that the air pressure is adding enough acceleration onto the cab to equal 1 mile per hour additional per 10 miles.
Okay, let me jump.
You should be able to show how it's happening.
Hold on, dude. If you guys are going to do a one-on-one, let me know. But otherwise, people are trying to get in, so you got to at least leave some room.
I'm still voting for move on. I have a really good subject to bring up next. And
if you guys want to do a one-on-one, you can. But it's like there's interruptions.
No, I want to hear what you have to say, Gino.
I just want to say
We've been
briefly,
moving
like
on for 10 minutes.
this would be. Well, I just wanted to add to it that if you're going 500 miles an hour in a plane, the 10 miles that Big Tech mentioned would be one. It says 1.2 minutes. So 1.2 minutes is the time it takes to fly 10 miles at 500 miles per hour. So that's like, roughly, like if you want to say like 80 seconds. So every 80 seconds, you'd have to increase a mile per hour.
Laterally, right?
It's
You
not-
get a 1 mile per hour
that's
acceleration
negligible. That's
increase on the side of the cabin, per minute and a half or whatever.
That's close to
But
what I
because
said
Dick, you
earlier, which
understand
was
that's-
1.7
that's
miles
why
per hour every minute.
Yeah,
There
it
you go.
depends
That's
on.
why-
Okay, yeah, it depends on what speed you're going and stuff, and then other conditions, of course. But that's just assuming one consistent type
And
speed.
that's going to be
But-
so negligible compared to wind conditions. That's going to be like a tiny little fraction of all the things that the plane's dealing with. So it's like lost in the wash of the wind going all over.
Right.
the place.
So you're saying it's lost in the wash.
Sure, but when you
still
say
has
it's
to happen.
negligible and imperceivable and stuff like that, that makes it unfalsifiable. You understand that, right?
Yeah, and,
Right, so
and it
since
contradicts
it
the
is
idea
that,
that
you
it has
can't
to happen.
claim that airplanes are doing something that violates the laws of physics because you have no proof of that. We don't have a test for that.
No, I'm
No,
not saying that airplanes are
I
doing
think you're
anything.
missing like
I'm saying that airplanes
if you're
do
saying it's
exactly what they're
unfalsifiable,
supposed to
you're
do.
making an unfalsifiable claim without evidence. You
I'm
can't
saying
prove
I
it,
think
or-
this
or
is
you
what's
do.
happening, and he's saying I don't think that is happening. And it's like, well, prove
No,
it.
wait, Big Tech. You're saying that
Okay,
that's
so you're not saying
happening,
it
but
actually
you
is
can
happening. You're
ignore it.
not making the truth claim.
Hold on,
You're
you guys.
saying
This
it's
is
happening,
right.
but
This
it's
is not being
negligible.
coordinated. Hold on, you guys are talking. I know New Perspective wants to get in, but we have to somehow go one at a time. Can I just say my second point? Actually, I'm just going to take this to say my thing. Let's just give each other like 30 seconds. Let's just no one monologue. That's all. As long as no one goes
Yeah, I
on for
got
like
next
5
question.
minutes. Just don't go on for like 5 minutes. Just like 30 seconds. Keep it. Yeah. And then we can go one at a time because there's a lot of points on the table.
I'm running a
Anyways,
timer.
Okay, for real. The second part, just of what I was going to say, is that in terms of this mechanisms being claimed, the atmosphere going along with the globe, everything that we've been discussing, the thing that links it back in terms of is it physics or is it not, and etc. That's why I brought up: is there any way to replicate this claimed physics? Because if not, then it isn't physics in terms of something that is tangible, that is physics, as it would be a claim that is claimed physics. But that's the thing about then who's able to go to space to claim to verify that and all that whole component of it. So that's why it's kind of like this middle ground. But I was just that's why it brought me back in terms of this being like if the globe position, the thing, if it could replicate it.
Time 30 seconds.
I know if it could replicate it, you got to give me like a 5-second warning, like a ding before 5 seconds. That's what we.
All right, 5-second warning.
That's what we've done before. And then someone wants to go longer, they can go a little longer. But anyways, no, just the final thing is just. Does that mechanism exist? So for the globe position to say yes, it does. If they could replicate it or show it in any way, shape, or form, that would be a strong thing that it is physics. Because then, you can, whereas if you can't do that, then it leaves it into this unfalsifiable. I'll just be kind and I'll say possible pseudophysics. Possible pseudophysics.
Yeah.
I'll answer your question.
I'll
on
go.
behalf of
Let me go 30
the
seconds.
Globers.
Resetting the clock.
I would say
I wanted to
I would
address
say
what Big Tech said.
it's like replicable mechanically. The mechanism is like a replicable, but not on a globe. They wouldn't be able to do it on a globe. They have the scaling fallacy, like you mentioned. But I do think that you could have like this big long warehouse or whatever showing these negligibly imperceivable changes in lateral movement and establishing the concept. But I did want to say, in terms of, we talked earlier about separating the systems between the lateral movement, like the
5-second warning,
increasing air mass, and then you're just messing me up right now, and the wind systems, right? And I think that the only issue with treating them separate systems is the fact that they claim that the Coriolis, like the wind patterns, the wind cycle, the clockwise in the north, south, counterclockwise in the south, is caused by the rotation. So that would be the weird.
All right, let me go with my 30 seconds. Big Tech said that it's unfalsifiable. We're making an unfalsifiable claim that it doesn't happen. But the thing is the pilots taught
Big Tech.
to treat the Earth. The pilots taught to treat the Earth as stationary, right? So the claim is that it's not stationary, even though he's taught to treat it as stationary.
I don't like the 30-second clock, man. 30 seconds is not enough.
So wait, are you still hearing me?
Yeah, right now we should have like a 1 minute if we're gonna do that. But I think as long as we just no one should interrupt anyone. Don't monologue. Just give your point. Make it concise as you can. Okay. And no one should interrupt anyone. So when it's your mic time, you get it. You got it. But when someone's done, yeah, that's where we either could have a list or a queue. But I mean, if two people jump in, they just have to decide who goes. And then ideally, let's say after you're done, New Perspective, let's say Big Tech and Percentage go at the same time. Ideally, one pulls back, one goes, and then it's just known that like the other one goes after that. Like it's kind of like, I think of it as like synchronized swimming. I mean, having an open panel style like this, it allows for a unique, like live organic type of discussion. But then, yeah, it is like you can have like a traffic jam.
Right, everybody try to keep aware. All right, I'm going to start over.
Big Tech.
Wait, hold on, wait.
Saying that
Can
it's
you hear me, guys?
Give new perspective to the mic. He's got the mic. I mean, to be fair.
Yeah. Can you hear me right now? Am I coming in low or something?
You were, but you're better now. Something just changed?
Okay. But I just turned my headset off, or my earbuds. So, yeah, so the claim that, so pilots are taught to treat the Earth as stationary, right? The claim is that you're taught to treat it as stationary even though it's moving with a tangential gradient. That would require that the plane does move faster eastward as it goes towards the equator. And the claim is that happens regardless, and the pilot can always treat the Earth as stationary regardless of what happens, right? So that's where you're making the unfalsifiable claim. And if you're saying it's so negligible, but we know it has to happen. So you're saying it's lost in the wash, but it's essential that the plane is moving in perfect lockstep, in perfect sync with the 1,000 miles an hour runway so we can treat it as stationary. So that has to happen regardless if it gets lost in the winds or how little you can minimize it in your mind. It's still 100 miles an hour every hour that it needs to go eastward. And if it's going the opposite direction full force, and it gets even worse, you talk about these jet planes that can fly 1,000 miles an hour, right? They can fly as fast as the supposed rotation of the Earth, 2,000 for some of these things. And they can hover in midair with 40,000 pounds of thrust resistance, right? So could the pilot, this is my question for Big Tech or anybody else, could one of these jets get out of sync ever with the Earth, no matter how hard it tried, and just show the Earth rotates separately from the plane, right? East to west underneath it as it goes south. It can fly 1,000 miles an hour. It can surely get out of sync with the Earth. It's got 40,000 pounds of thrust resistance. It can make sure that it doesn't have any kind of effect from this eastward wind that's not a wind that's supposed to be pushing it in sync with the Earth. It could resist that all it wants, so we could just show the Earth rotates.
Is it my turn?
Yeah, I think they call that outer space. That's what they call that. But
yeah, exactly. That's how you. Yeah, exactly. I was going to say, just leave the atmosphere, and then there you go.
But it's flying as fast as the rotation, literally, supposedly.
Yeah, so
it's flying 1,000 miles an hour.
I mean, so technically, every single moment that it's flying, it is out of sync with the Earth. It's just going wherever it wants. It's flying through the air, not the ground.
What? Out of sync.
So,
I knew you'd interrupt. Come on, dude. Give him his 30 seconds. Let him say something.
So if the Earth's going one way and it's going the other direction, is it in sync? Of course not. If the Earth's going, east to west and it's going west to east, then or the other way around. But so yeah, it's always out of sync with the Earth. That's what traveling is. But if you mean that if you wanted to have no dynamic influence from the Earth, well, then you'd have to remove it from the air, because the air is receiving input from the Earth and the plane's receiving input from the air. So there's no way to disconnect the plane from the air. It's an airplane. So it's riding in the air. It's suspended in the air, relies on the air. It's propelling through the air. It's locked to the air, and the air receives input from the Earth. So it's never out of the system of the Earth ever, because it's in the air, and the air is part of the Earth system. So the only way out would be to go into the vacuum outside of the matter. The material that's touching the planet, it'd have to leave that space.
Well, how is it going with the ground though? How is it going with the ground? Just real quick.
It's going with the air, which is going with the ground.
How is it? Well, if the ground is separate from the air, how is the air going along with it?
How does the air go along with the ground?
Yeah.
Well, there's just like moving. Well, it's in rotation that is the same as the Earth, except for like in the troposphere, which is the lower up to 12,000 feet, it's minus 1 to 2% of a difference of the Earth's speed, rotational speed. So there is a drag. The atmosphere has a little bit of a drag. So it's not in perfect lockstep, but it's about 98% perfect. So the atmosphere is just moving with the Earth.
It's like a blender.
So it's just going with it. And the only reason it would stop is because of the law where, it would require another force to act against it to stop it from rotating with the Earth. They would have to it would have to meet a counter oppositional force. So in my last 5 seconds, I'll say, I want to pitch, we can say, so that's what I want to say about this. And I want to pitch my new subject. I want to talk about the space shuttle flight. When you guys are ready to move on from this, so we don't loop forever, I have
basically just like a blender with friction.
Yeah, that's
fair. A blender that also has some of the blender pieces going in the opposite direction, which never happens in a blender.
Yeah, it's not a blender.
Okay, but that's the concept. It's just a concept.
Well,
you realize what you described as the concept. There's no dynamics to it whatsoever.
No, the dynamics is air pressure. That's a dynamic
Air
force.
pressure. What? That's not air pressure. Air pressure makes it go
pressure is a
faster
dynamic
eastward.
force. Pressure is a dynamic force.
Yeah, but
So there's
air pressure is not moving eastward only.
Yeah,
well,
bro,
it's moving all over, but in general, on average, in totality, it is going that direction only. Absolutely.
On average, isn't good enough. All these estimations
Well,
it has to be in perfect lockstep. The atmosphere is not even said to be in perfect lockstep, but the plane would have to be in perfect lockstep. Doesn't matter. Even that wouldn't work. You have to have perfect lockstep for the plane to treat the Earth as stationary. There's never,
not necessarily.
there's never a moment where the ground is moving.
Let's not loop again. Let's not loop again. Let's not do it again because we've already established the plane is not dependent only on the air and the dynamics of the Earth. It also has its own input thrust. It has its own forces. It has fuel. The fuel is what takes the plane where it wants to go. It's not just
and
the
it can
air.
fly against the spin.
So it compensates.
And it can fly against the spin.
Flies against the spin and you fly with it, but it's flying through a medium that is spinning. Just like
you realize that's just the concept. You realize it's just a concept that fixes it.
Well, you know what's wild about that though? If you bring in like ether wind or ether drift, because so the thing is like when you're standing on the ground, when the stars move, they claim that those stars moving on the globe is because you're on a ball, that's moving. That meaning, why are the stars moving? Oh, you're on a ball and that's why they're moving. Whereas from the perspective that you're on a stationary surface and those stars are just moving, in both of those scenarios, there could be a very light drift, as it were, because of this basically the speed those stars are going, which actually is like 1,000 miles an hour. Like the stars at the equator are going the claimed 1,000 miles an hour, just like the sun, right in that range. So I mean, those stars that look like they're just trickling along up there, well, they're going 1,000 in the globe model. Well, actually, even on a planar Earth as well, because they go all the way the distance of the equator, if that distance is close to true, but that's why like 24,000 miles roughly, and then 1,000 miles an hour, 24 hours in a day. So that's why you're getting
Polaris doesn't move at all. It goes all the way down to zero. Exactly.
Wait, I got to make sure Big Tech knows something before we move on. Big Tech, when they say that the jet stream is moving 200 miles an hour, they're saying that that's 200 miles per hour faster than the rotation. So technically the plane would be going 1,200 miles an hour. Right, so you could come right out of that jet stream.
No, you got that wrong. It actually goes against the rotation.
Sometimes it does. They go in both directions. But I'm saying if there's one that's going faster than the rotation, 200 miles an hour, you could jump out of that jet stream going faster than the supposed rotation of 200 miles an hour, and you'd still be perfectly in sync with the ground. You could land right below it immediately, no gradual catch up of any kind of imaginary mechanism. It's only the wind going faster than a stationary Earth, not the Earth moving as well as the wind moving faster than the rotation. Just so you know, that's what the claim is of the globe. It's going 200 miles per hour faster than the rotation.
Yeah, I know.
When we likened it to the blender,
when we likened it to the blender,
you said except
that's just the jet stream.
When we likened it.
We're talking about the totality of the atmosphere that is flying through. It's not always in the jet stream.
Yeah, but if the jet stream is making it go 200 miles per hour faster than rotation, how is it all of a sudden going in perfect sync with the rotation when it jumps out of the jet stream?
It's never in perfect sync with the rotation. It's traveling, my guy. Traveling means you're out of sync with the rotation. That's how you travel.
Right, but the conserved momentum of going 200 miles an hour, it jumps out of the jet stream, all that just disappears automatically and the ground's stationary all of a sudden again?
No, it's going 500 miles an hour through the jet stream. The jet stream's helping it go 500,000. When it leaves, it decelerates so it can land.
You're saying that he has to.
It's not going 500 plus 2.
So he has to slow down to be in sync with the Earth that's moving slower than he was?
No, it has to slow down so that it can land on the airport that's sitting still.
Yeah, it's sitting still because it's stationary. That's the only way that would be. If he was going 200 miles per hour faster than the rotation, he would have to slow down 200 miles an hour to be as sync with the Earth.
Dude, I don't know how you can. I don't know how you can say what you're saying and not hear.
The argument is it would slow down without knowing. It would automatically slow down.
That's crazy. It's like how do you step off of an escalator without?
I want to get in. Bro, let me allow it. I want to get in real quick because when we likened it to the blender, new perspective, you said except in the blender you have the thing you'd have to have things going in the opposite direction, and I don't think that's accurate. I think you'd have things going slower, right? But in their model, like the rotation of the Earth is everything's still going, generally speaking, plus or minus 1,000 miles per hour at the equator, in one direction, So whether there's a wind going in the opposite direction locally, it's still, generally speaking, still going like let's say, if it's say 100 mile hour per wind in the opposite direction, it's still going 900 miles per hour in the direction in the rotation that they're talking about. So in the blender, you're not going to have anything going opposite to the flow. It's just going to be slower or faster.
Yeah, the concept is if it slows down, it appears to be going the opposite direction, but it's just slowed down compared to the overall motion going eastward, right? So the westward.
There's also counter vortexes, like counter vortices in all motion as well.
Does anybody want to move on to the space shuttle question?
Yeah, but I just want to make sure you know that it would actually be going 200 miles per hour faster than the rotation. It would have to slow down to meet the rotation. Just so you know, Big Tech, that is the claim of the globe.
I know planes have to slow down in order to land. I know that.
They don't slow down to meet the Earth rotating at a different speed eastward than the plane. They never do that.
Regarding moving on to
drifting 200 miles an hour eastward in the jet stream?
Yeah, that's 200 miles per hour faster than the supposed rotation. That's the claim of the globe.
Let's save some for tomorrow, guys. Let's save some for tomorrow. Matthew, go ahead. What do you
crazy.
think?
I was just going to say, regarding moving on to a different topic, I believe that New Perspective would not like to move on, and that we should he wants.
No, I'm done. I've had this argument over and over again. I've made my point.
Space shuttle.
I'm late for another date actually, so I'll probably leave. But Big Tech, look into it. DM me back when you get an answer.
Yeah, draw a picture of what you think's going on. Maybe I'll understand like what
I did. I sent you all my memes. There's tons of pictures explaining exactly what I've been saying the whole time.
You guys are so cute. We honestly got to set up a 1v1 dumpster fire between you two.
But a pleasure talking with you, Big Tech. You're in the process, and big ups. If you want to find out if we're not on the spinning ball, I'd say most people here say you can find that out.